Hey everyone, so here's your lesson for Wednesday, May 6th. We're starting a new unit today called Quadratics. Okay, we're going to talk about quadratic functions. And specifically today we're going to talk about interpreting the graphs of quadratic functions and what they look like. So first of all, let's talk about symmetry. Let's go back to elementary school and talk about symmetry. Okay, symmetry is just two things that are identical side to side. So if we look at these shapes here, we can see the lines of symmetry. Okay, and the parallelogram has no symmetry, nor does the trapezoid. So quadratic functions, okay? This is the form of a quadratic function. It's always going to take this form, a squared plus bx, ax squared plus bx plus c. Okay, you know it's a quadratic function if it looks like that. And quadratic functions will always have this look to it. Okay, it'll be in a U or a V shape. And I'm actually going to erase that and say that quadratics will either look like this. Here's one graph, here's another graph. They can either look like a U, like you see in the graph below, or they can look like an upside down U or a V. Okay, that's a quadratic function. They'll always look like that as long as it starts with ax squared. So, pieces of this function on the graph, we have names for them. So the first thing, the blank is the vertical line that shows the symmetry of the graph. Okay, so this is what we're talking about here. When we talk about symmetry, if I were to fold this line over on itself, it's identical. So we call this the axis of symmetry. Okay, that's the line that it makes it symmetrical. 2. The graph of an axis of symmetry is, the graph has an axis of symmetry of 1. Okay? And we know that because it lies on the point where x equals 1 right here. This is x equals 1. So we're going to say x equals 1. So the axis of symmetry is x equals 1. And I'll actually do this. X equals 1. 2. The x-intercepts go by many names, including roots, zeros, and solutions. Okay, so anytime the question asks, what are the roots? Or what are the zeros? What are the solutions? It's saying, what are the x-intercepts? Okay, on this graph, the solutions or the zeros or the roots are here. Okay, we have x equals -1 and x equals 3. So the roots or the solutions here would be x equals -1 and x equals 3. Next one, the y-intercept is the c value of the equation in standard form. So it's this. It's the c value here. Okay? That's known as the y-intercept. I'll abbreviate that for short. The y-intercept is also found on the graph wherever it crosses the y-axis. So here's the y-axis, right? This line. So the graph crosses the y-axis right here. It says y-intercept. So we have y equals -1, -2, -3. Y equals -3. The vertex is also called the turning point. I'll make that a different color. Meaning, where's the very bottom or the very top of the line? In this one, we're going to have a very bottom, right? Because it dips towards the bottom. So the vertex is right here. Okay, it's the very, very bottom point. So we either have a minimum, if the graph looks like this, we're going to have a minimum. And if the graph looks like this, we have what we call a maximum. the opposite way. This would be our maximum. So in the graph that we're looking at, the vertex here has a minimum point, okay, because it's a U shape. It faces down. All right, let's look at a quadratic function again, okay? The a is called the leading coefficient. Whatever this number is called the leading coefficient. It's going to be a number. So if a is positive, if it's a positive number, the graph opens up and has a minimum, like what we were talking about before. So opening up is this one here. Okay, for example, when a is greater than 0, or when a is positive, in other words, this is going to give us a minimum point. As opposed to if a is negative, the graph opens down and has a maximum point. So in this graph here, it opens down. A would have to be a negative value, and we can say it has a maximum point somewhere right here. Okay? That we just use this. This is good information to have if you don't have the graph in front of you and only the equation. Okay? So let's actually look at a graph now. Okay, example 1. Use the graph of the quadratic function below to fill in the table of values and answer the questions that follow. Okay, let's fill in this table of values here first. Okay? The way we're going to do this, 2 different ways you could do this. Okay, you can type it into GeoGebra. You can type this function into GeoGebra if you want. You're going to get the same graph that you see. So let's type it into GeoGebra. So we have f of x equals x squared minus 4x plus 3. Okay, that's the graph. Now, I want a table of values to where I can kind of see what the graph looks like. So, I guess, and it's easier for me to write on here, let's go from -1 to 4, because that'll give us a good depiction of all the values that we actually see on the graph. So I'm going to go back to GeoGebra, and I'm going to say table of values from -1 to 4. Okay, so I'm going to fill the graph in, or my table in now from GeoGebra. I have -1, 0, 1, 2, 3, 4, up, and I guess we'll go back and we'll put in 5. Okay, so we're going from -1 to 5. I can edit, and I can put in 5. So now I just copy my values into the table. 8, 3, 0, -1, 0. Three and 8. Okay, and you notice like it matches up. Okay, I'm going to get rid of some of my markings here. If you look, -1, 8, well, that matches up. That's a point on the graph. Okay, 0, 3, 0, 3, point on the graph. 1, 0, 2, -1, 3, 0, 4, 3, and 5, 8. Okay, all points on the graph. So now that we have our table filled in, part A says, what are the x-intercepts, or the roots, zeros, or solutions? All the same word. So all I'm doing is I'm searching for my x-intercepts. Where does the line cross the x-axis? Here's the x-axis. Okay, the line crosses the x-axis here and here. So we're going to put it in set form. Whenever we're just using points, we're labeling it as a set, which means these brackets. Okay, it's a set. As opposed to parentheses, which is a point, this is a set. It's just 2 different numbers. Part B. What is the y-intercept? That means where does it cross the y-axis? So I go down the y-axis until I hit the graph right here. Okay, so I have y equals 3. Part C. What is the vertex? Well, the vertex is either the very minimum or the very maximum, and because we have a U-shaped here, it's a minimum. Okay, so the vertex is a point. The vertex is going to be the point 2, -1. Part D. What is the sign of the leading coefficient? Okay, well, the leading coefficient is always going to be whatever number is in front of our first value here. And if there's no number there, we can always put 1. So the sign of 1 is always positive, right? There's no negative, so it must be a positive. Which tells us, part E, does the vertex represent a minimum or a maximum? Well, if it's positive, we have a minimum. You can also tell by just looking at the graph that this is a minimum value. F. Draw the axis of symmetry. What is the equation of the line you drew? Okay, well, the axis of symmetry is going to start at the vertex, or it goes through the vertex, and all the way up the line. Okay, this is the axis of symmetry. This is where we see a mirror image of itself. Okay, and this is the line x equals 2. That's the equation of the line, x equals 2. You just look at the x value, it goes over the 2, and that's how you know it's the line x equals 2. Alright, one more example. Okay, same thing. Use the graphs of the quadratic functions below to fill in the table of values and answer the questions. Okay? I'm not going to put this equation into GeoGebra. I'm going to use the graph that I'm looking at right now. Okay? So I'm just going to look at some points here. Let's see. Can I see x equals -5? I start at x equals -5 and I go down, and I can see that it hits the graph at -5. So we have -5, -5. -4 crosses at 0. -3, 3. -2, 4. -1, 3. 0, 0. Just right here. And 1, -5. That pretty much covers the entire graph. I can't really see any more of the graph. So there's my points. Part A, what are the x-intercepts? So the values of where it crosses the x-axis. So it crosses the x-axis here and here. So you can also write it like this. You can say x equals -4 and x equals 0. Okay, so x equals -4, x equals 0. B, what is the y-intercept where it crosses the y-axis? Well, here's the y-axis. So I just go down until I hit the graph. Oh, y equals 0. C, what is the vertex? Okay, what is the turning point? The turning point is right here. Okay, that's the point -2, 4. Part D, what is the sign of the leading coefficient? Well, the leading coefficient is going to be the number in front of -x². Again, there's no number, so I can put 1. But just keep in mind that's a -1. So we know that the sign is negative. E, does the vertex represent a minimum or a maximum? Well, it's a maximum. Right? This is the highest point on the graph. Part F, draw the axis of symmetry. What is the equation of the line you drew? Well, it's just the reflection point. So I use the vertex and I draw a line straight through the vertex. This is the axis of symmetry. Okay, and it crosses the x-axis at x equals -2, right here. And that's it. It's just identifying parts of a quadratic function. Okay, and 2 quick questions about the same graph we just did. What is the relationship of the axis of symmetry and the roots? So if we go back and we look at the axis of symmetry, okay, here's my axis of symmetry, and the roots, remember the roots are my x values. And actually I'll kind of get rid of some of this stuff so we can see it a little bit easier. It gets a little crowded. So the axis of symmetry is here, and here are my roots. Okay, really what the axis of symmetry is, it's the halfway point, okay, between the roots. Between this point and this point it's half the distance. So it's the halfway point between the roots. And part H. How can we find the axis of symmetry using the table? Okay, well, if I go back and I look at my table, we're always going to look for where the vertex is and use the x value. So if you look at my table here, look at the pattern. Okay, look at what we're seeing. What is the highest value here? Okay, you can see that all of a sudden we go -5, we're decreasing, decreasing, decreasing. We get to 4, and then we start to decrease. 3, 0, -5. Okay, this is the highest point in the table. So that's just using the table. So you can find the vertex and use the x value. Or sorry, find the highest y value is what I meant to say. Okay, the highest y value here is 4. So my point is -2, 4. Alright, that's it for today, guys. Please take a look at the assignment. It's going to be a graph very, very similar to this and questions exactly the same as this. Okay, so if you watch the video, you should be able to do it. But please email me, text me if you have questions. Good luck, guys.